All right, so we've got this info here. We've got the height and the weight. And the first step here, it says create a scatter plot. So we need to put these values in our calculator. So go ahead, get out your calculator. Do you remember how to put lists in? We did it last unit, so I hope you remember. Go to Stat, Edit, and then put your values in. So I'm going to put the height in list 1, so 58. All right, I'll give you a sec to get your lists in there. No, you'll just need to keep track of them. Like, if you look further down, like question 6 there, it says predict the weight of a boy who's 65 inches tall. So to me, the weight is your Y value. Okay. And so I put that in the second list, but you just have to keep track of which one's which. You found your calculator.
But I might just can't find my packet.
Oh, you can't find your packet? Let me grab another. Always make a couple of.
Layer thing. Yeah.
All right, guys. How do we make a scatter plot on your calculator? Anybody remember? Stat plot, good place to start. Yeah. So second y equals will take you into stat plots. Yeah, I'm going to pick the first one, turn it to on. And then the type, that first one highlighted, that's the scatter plot. I have my X's in list 1. I have my Y's in list 2. And then I'm going to push zoom 9 just so I get a nicely sized, like it fits well kind of graph. That's zoom stat. So there is my scatter plot. If yours doesn't look like this, let me know and I'll come help. Yeah? Sure. So second y equals. And then enter into that first one, make sure it's turned on. And then here, I'll just show you. That is the scatter plot. And then I've got my X list and Y list. It's my L1 and L2. And then zoom, which is that middle button at the top, 9 for zoom stat. We're there? Worked? Okay. All right. So guys, next to your list here on your paper, let's just make a little sketch of this. And does it look fairly linear? I mean, we only have 8 data points, so yeah, pretty good, fairly straight line. So we'll go with that. So I'm just going to make a little sketch. I'm not going to truly label this, but I am going to note like where the height and the weight are. Let's see, this was it. inches. And then just the general shape. And I don't have my calculator up while I'm looking at it, so something like that. We'll pretend that my scatter plot looks like your scatter plot. All right, so we've done number 1. Okay, number 2 says calculate the value of r and r squared and interpret each of those values. The way you calculate those is by actually doing the linear regression on your calculator. So we pull the calculator up again. And we're going to probably do this twice because anticipating an issue you guys are going to have. All right, so we're going to go into stat, calculate. We want to go down to number 8, the linreg. I know there's a bunch of different linregs on here, linear regression. Pick the one that is a plus bx, because that's the format we want to use for statistics. So I'm picking number 8 here. So this is, again, stat, calc, number 8. So we'll go ahead and click that. You've got your X list, your Y list. Frequency list we don't have. Store the regression equation. If you want to see what the line of best fit looks like in your scatter plot, this is where you'd want to use storing this in a y equals. So we have a shortcut. If I do alpha, I always forget which one it's under. Yeah. Alpha trace, you don't even have to do stow. If you just put alpha trace and pick the y1 where it says store regression equation, you see that right here? Okay. Then it will store it in the y1 for you. Go ahead and hit calculate. Did some of you get an r and an r squared value under this? Did anybody get that? Yes? Okay. If you didn't, if yours looks like mine, that means we're missing something. You have to turn the diagnostics on your calculator to get the r and the r squared value. So we're going to go ahead and do that. We're going to go into the catalog. So second 0, do you see that down at the bottom where it says catalog? You can just scroll down to the D's. You can push the D, the little letter there that's in green to get to the D's. And then scroll. We are looking for diagnostic on. There's diagnostic off. We want diagnostic on. Yeah.
Will you have to do that every time?
Nope. Just once. If your memory gets reset, then you have to do it again.
How do you get that?
So catalog, do you see that in blue above the 0? At the bottom of your calculator. So second 0.
Oh, yeah.
Yep.
So second 0.
And then you're in the catalog and then just get to the D's. And then you push enter. And you push enter again until it says done. And then we're going to do that regression again. So stat, calc, number 8. I'm going to store my regression equation again. Alpha trace takes me into the shortcut menu. Calculate. I have a lot more numbers. Let me pause here for a second, make sure you guys are clear. Yeah.
I still just have the Y and T.
Did you do diagnostic on, enter, enter? Okay. I know, it's a lot of entering. So try it one more time. You're going to be really good at doing this linreg. Everybody else have all these lovely decimals? Yay?
Yeah.
Woo, okay, good. All right, we're all here now. And by storing, you can see it down, my graph shows up here. By storing the equation, it actually shows the line of best fit through my scatter plot. We don't really need that for anything, but it's just nice when you're like, yes, that actually fits through my dots nicely, okay? All right, so we need to jot down the R squared and the R value here, and then we'll talk about what those actually mean. Let's see if I can squeeze everything in here. I did not give you guys a lot of writing room on this one, so I apologize. So the R was 0.939, and the R squared was 0.882. We're going to talk about the R value first.
Does it matter if R squared is lower or uppercase R?
Doesn't matter. All right, guys. What does R tell us about? Just R, not R squared. You guys remember from last time? Yeah, what do you think? Yeah, so it tells you if it's like a strong or a weak correlation between the two. So what do you think, guys? 0.939, is that pretty strong? Yeah, it's close. The closer you are to 1, the stronger it is. So what we would say here is that the association between height and weight is linear and, oh, we can say linear, positive, and strong. Okay. Now, we can say it's linear also because we looked at the scatter plot and we said, yes, that's fairly linear. And also because that R value is pretty close to 1, a linear model makes sense. If your R value was like 0.17, that's a terrible model to use, okay? We don't want to use that. We don't want to use that to make any sort of predictions. So I think the R value, that makes sense. Like you can see it, you can see what direction it's going. The strength is pretty easy to determine. R squared is a little just weirder to write. So what we say the R squared value is telling us is that about 88% of the change in weight can be explained by the change in height. Again, guys, I know I'm writing small. If you can't read something, just tell me, okay? So anytime you're doing, what does the R squared value tell us? It's the percentage of change in your Y value that can be explained by the change in your X value. Okay, so you'll put the context in there, but every time that's what you're doing when I say interpret the R squared value. Okay, coefficients of the least squared regression line. So we need the y-intercept and we need the slope. Those are the two things that your calculator gives you when you do the linear regression. So my y-intercept, also known as b sub 0, Let's look at our calculator. Which of these numbers up here is actually the y-intercept?
Oh, okay.
Yeah, it's weird. It's listed as A. Okay, so I know that's misleading. We normally write b sub 0 for the y-intercept and b sub 1 for the slope. Here on your calculator, it's A for the y-intercept and B for the slope. So the negative 91.923, that is your y-intercept. So we'll jot that down. I'll just say negative 91.92. And then slope, which is the b sub 1. That's the 3.25. Okay. Everybody see it on there? So guys, I'm going to go up above and actually write the equation. I've got a little more room up top here. I'm going to write it two ways. I'm going to write just with the symbols. So predicted y would be equal to negative 91.92 plus 3.25 times x. Or we could say predicted weight put pounds in parentheses is negative 91.92 plus 3.25 times height in inches. When you're writing these, remember you're either going to want to write it with the words, or somewhere off to the side you can define what the symbols are and then just use the symbols. So we've got our equation. All right, plot your regression equation on the scatter plot. So let's look at that on our calculator. Now that we've calculated all of this, go back to Zoom 9. And if you stored your regression equation, you should see it on your graph now. Okay. We're not doing a lot with this, but again, it's confirming that yes, you have the right equation for what we plotted, because it looks like it fits pretty well. And you can sketch it in on yours if you would like. Just draw your line as best you can. All right, number 5, interpret the coefficients in context. So that's talking about the y-intercept and the slope. So let's do y-intercept first. So our b sub 0 was negative 91.92. What does that mean? Like, what does that represent? It's a y value of negative 91.92 when x is equal to what? Not 1, 0. Yeah, we'll do the 1 when we get to slope. Yeah, so it's saying that someone who is 0 inches tall would weigh negative 91.92 pounds. Yeah, remember when we said the y-intercept usually makes no sense? This is another example of that, okay? So, and you'd say it, we would predict, because that's what we're talking about. We're always making predictions here. That a boy 0 inches tall would weigh negative 91.92 pounds. You have to write it out in context, but rarely will it make any sense. Now the slope should make sense. Our slope here is 3.25. This is talking about, remember, slope is y, change in y over change in x. So it's talking about the change in weight related to the change in height. That's what the slope is dealing with. So the way we word it, we say the average increase in weight when height increases by 1 inch is, and I left out increase in weight. Sorry guys, I left out words here. I just skipped what we're talking about. So the average increase in weight when height increases by 1 inch is 3.25 pounds. It's change in y over change in x. Anytime you're interpreting slope, that change in x is always going to be a 1. Okay, so here we were talking about height increasing by 1. Whatever the context is, x will be 1. Okay. All right, guys. How do we predict the weight of someone who's 65 inches tall? Yeah, what do you think, Josh?
65 is correct.
Yep, plug 65 in for x. So I'm just going to do predicted y is negative 91.92 plus 3.25 times 65. So go ahead and key that in on your calculator. What do we get for our predicted height? Or I'm sorry, predicted weight. 119.33 pounds. Are we okay on 6? We're good with just plugging it in, right? What about number 7? Predict the weight of a boy who's 77 inches tall. Anybody have any concerns about predicting the weight of a boy who's 77 inches tall? Yeah, let's look. We had data points. Our lowest was 58 inches and our highest was 72 inches. What is it called if I try to predict for 77 inches? Extrapolate. Do we want to extrapolate? No, guys, I drew a frowny face on that last time, okay? We don't want to extrapolate. So we don't have to do this one. We just say, no, extrapolation, we're not going to do that. So don't just blindly plug values in. Make sure you look at them and that they fall somewhere within the range of values you've been looking at.
So if that was a do like probably put like
Yeah, like this is dangerous. Don't do it. All right, number 8, the residual for the 62-inch boy. Okay, we talked about residuals a little bit last time. Let me remind you of what a residual is. So residual is actual minus predicted. So let's look up here. Did we have a 62-inch? We did. Okay, we had this guy. So his actual weight was 105. How would I find his predicted weight? Yeah, the formula. So actual, I said, was 105. Go ahead and plug that 62 into the formula to get the predicted. Good. Predicted is 109.58. So your residual then is negative 4.58. So make sure you remember that the residual is actual minus predicted. All right, guys, we're almost there. 3 to go. Are we okay on number 8? Okay. All right, 9. Does the residual plot suggest that linear regression is appropriate? Okay. First, we have to see how we make a residual plot. So we have to do that on the calculator. What we're looking for in the residual plot is we want it to just be a cloud of dots, okay? Just look like a random scattering in your residual plot. That's a good thing. If you see some sort of clearly defined pattern in your residual plot, that means the regression you used wasn't appropriate, okay? So let's pull up your calculator here. You can only check the residuals after you've actually calculated the linear regression, because then your calculator has saved what those residuals are. All right, so we're going to go into our stat plot. We're sticking with the scatter plot choice, and your X list is still list 1. But your Y list is going to be different, okay? We want it to actually say residual there. So we find that, do you see above stat where it says list in blue? That's where we need to go. So we're gonna push second stat. It's number 7 for me. It might be number 8 on your calculator though. We want resid, okay? That stands for residual. So just push the number or highlight that one. Again, it might not be 7 on yours. So yeah, let me go through it again. So we're in our stat plot. We're still doing a scatter plot. X list is still list 1. And then Y list, we need to say residual. So I'm going to go second stat to get into this list menu. And then pick whichever one says residual for you. And then zoom what? What do you think? 9, zoom 9. All right, it's a decent cloud shape. We only had 8 points to work with, so this is good enough for what we had. That is your residual plot. You can see my original one in the littler box over here. That's showing you, the actual scatter plot and your line of best fit. This is showing you how far each of those dots is from that regression line, basically. Okay? some are above, some are below. But you just need to be able to make it and to see that, yes, it is a cloud. All right, are we okay on the calculator part there? Yeah, this we'd say, yes, this is appropriate because we see a cloud in the residual. Yep. All right, so we would say, yes, it is appropriate. Maybe. And just say residual plot. You can say shows a cloud or is randomly scattered, however you would like to word that. Okay, then are any of the boys outliers? So we could go through the formula, the Q3 plus 1.5 IQR, Q1 minus, but I don't think you probably want to do that, correct? No. Okay, so let's look on our calculator. We're going into stat plot again. Okay, but I'm not going to pick a scatter plot this time. I'm going to pick the box plot that will show outliers if there are any. And that is that first sort of box plot looking one. Do you see how it has like the dots on the end of it? That's telling you it will show the outliers if they appear. So I'm going to push enter on that. Okay. Now what we're making the box plot of, we're not making it of just the list of heights or weights. We're making it of the residuals. Because we're trying to figure out, are any of the residuals, like the distance from that line of best fit, really far away? So we, in our X list, want to put the residuals. Do you remember how to get to it? Second stat, good. And then whatever number it is on your calculator. Then zoom 9, maybe. All right, is that what your box plot looks like? Okay. What? No outliers, right? Guys, we don't have anything, like if you had an outlier, you'd see like some little like star looking thing past the end of your box plot. There aren't any of those, which means there are no outliers here. Okay, so the way you would describe this, you would, are any of the boys outliers? No. And you'd support that by saying box plot of residuals does not show any outliers. No outliers on residual box plot. So, because what we're looking at is, if you look at it individually, we're not concerned with is just someone's height an outlier or someone's weight an outlier. Is there like height-weight ratio, you know, because we're predicting weight from height, is that an outlier? And so you can't make a box plot of like two variables at once, but the residual tells you how far away someone's actual like weight is based on the prediction that you would get from your line of best fit. So that's why we use the residuals, because they're telling us like how the residual tells you how sort of unusual that person's ratio is compared to what we would expect with our line of estimate. Does that make sense? Okay. All right, guys, one more question. We can do this. Madison, you look like you don't believe me. All right, we've got 2 people considering moving into the Madison school zone. We have Stumpy, who is 65 inches and 275 pounds, and Sticks is 80 inches tall and 120 pounds. Which boy would influence the least squares regression line more? Sticks. I got a vote for Sticks. Anybody else? I think I heard someone say Stumpy. Sticks. Okay. Do you remember what we talked about made a point an influential point? What was it? Yeah, we're looking, remember the teeter-totter scenario? We want you way out on the x-axis. 80 inches is going to be much further out on the x-axis than the 65 inches is. Yes, the 275 pounds is very different than any of the other weights we've seen, but the 80 inches is going to have a bigger impact. If you think about your, you've got your points here, 80 inches is going to be way out here and 120 pounds. Do you see how that's going to pull that line down more than someone who was 65 inches and 275 pounds? Like that one might shift the whole line up, but it's not going to really change the slope of the line. Whereas this purple point out here is going to like make the slope of the line change. So influential is really talking about changing the slope of the line. The 65 inches, 275, that is definitely going to impact it, but it's just going to like shift it up, not tilt it. Does that make sense? Okay, so yes, Sticks would be more influential. Guys, that's our Unit 8 notes. Very different from our last few units. Okay, I'm going to pass out some classwork for you guys to start on. You do not have, we're not going to go over it today. I'll give you the rest of your religious observance day. Yeah, you can go. But next class, we'll go over this one that I give you. I'll give you a little bit of time to work. And we're going to do a second classwork on Thursday as well. Okay? Yeah, go ahead. So let me go ahead and stop this.